Hey everyone, Mr. Houck here. In today's video, we're going to be looking at a collection of problems that help prepare us for a Unit 1B quiz. Let's go ahead and get started. So here in problem number 1, we want to select all the statements that are true regarding the function f of t equals -4 sine of 2t minus 3. So to begin with, let's look at all the different things that are happening to this function from the parent function f of t equals sine of t. So the first thing that I'm noticing is a reflection over the x-axis for the parent function, which we can also describe as a reflection over the midline. So I'm going to say here in green, this first thing we see is a reflection over the midline. Okay, in red, notice that we have this 4 being multiplied to the sine, and that represents the amplitude. So we have an amplitude change from 1 to 4. The pink arrow is pointing to a 2 on the inside being multiplied to t, so we know that affects the period. So let's recall that for a sine function, the period is t equals 2 pi over b. Well, we can see that the b term is 2, so this becomes equal to, let me erase that, equal to 2 pi over 2, and we know 2 pi over 2, when the 2's will reduce, we just get pi. So the period is pi. Then lastly, in purple, we have this minus 3. It's on the outside of the parentheses, so we know this is a vertical shift of down 3. Okay, vertical shift down 3. So let's look at all of our answer choices that support this. Answer choice A says the amplitude is -4 and the period is 2 pi. Well, no, the period is 1 pi and the amplitude is 4. Amplitude is always positive, so this would be a false statement. B says the amplitude is 4 and the period is pi. That's true. C says the function has a phase shift of right 3. Well, remember that phase shift will be something added or subtracted inside the parentheses to t, so that's going to be false. But we do have a vertical shift of down 3. And then the last answer choice says the function has been reflected across the x-axis when compared to the parent function, aka reflected over the midline. That is also true. That's what the negative in front entails. Okay. Looking at number 2 here, we want to find the period of f of x equals 3 tangent of 2/3 x. Well, recall that for tangent, since the parent function of tangent has a period of pi, every tangent function will have a period of pi divided by the b term, and remember the b term is a number being multiplied to x. So that means we're going to have t is equal to pi divided by 2/3. Well, we have pi being divided by a fraction, so we'll do our keep change flip. That'll be pi times 3/2, which will equal 3/2 pi or 3 pi over 2. Both of those are the same. Okay, 3 pi over 2. Oh, I don't like that shape recognizer. Better, I guess. All right, so 3 pi over 2, that's answer choice C. All right, problem 3, select the equation of the cosine function that has the following features. Period of 3 pi over 7, amplitude is 2, vertical shift is up 5. So let's think about a couple things here. Number 1, if the amplitude is 2, that means the a term is either positive 2 or negative 2, okay? So I'm going to make that note here. A equals 2 or a equals -2. We haven't been told if this thing is going to reflect across the midline or not. But, you know, looking at our functions here, both a and b have a terms of 3 pi over 7 for a and 14 over 3 for b. Neither of those has the right amplitude. So we can go ahead and cross both of these out because they both have the wrong amplitude. Now let's think about the period. So the period is 3 pi over 7. And we know that for cosine, period is 2 pi divided by the b term. So since t, or since the period here equals 3 pi over 7, we can take this 3 pi over 7 and substitute it for t. So we would get 3 pi over 7 equals 2 pi over b. And then notice that we can use cross multiplication to solve for b. So we would multiply 3 pi times b, 7 times 2 pi, so we'd get b times 3 pi equals 14 pi. Go ahead and divide 3 pi from both sides. We get b equals 14 pi over 3 pi. And reducing by pi, the pi's will cancel. We get b equals 14/3. So if we look at our answer choices, the only option left between C and D that has a b term of 14/3 is D. All right, looking at number 4. Number 4 says, what is the period of the graph provided? Well, recall that a period is the horizontal length of one complete cycle. So we want to go into this graph and we want to identify one complete cycle and then try to find that horizontal length. Well, I can see that I can trace from here to here, and I would stop at pi over 2, because if I start highlighting any further than pi over 2, the cycle is just going to repeat itself. So we are looking at the distance, the horizontal distance, from 0 to pi over 2. Here to here, so we know that horizontal distance is just pi over 2. And then answer choice would be answer choice B. All right, problem 5 asks us to find the amplitude of the graph provided. So recall that the amplitude is the positive distance from the midline to either the maximum or the minimum, and that distance from the midline to the max should match the distance from the midline to the minimum. So let's start by identifying the midline here. If our minimum term is at -3 and our maximum term is at +5, that means the midline, or the distance halfway between -3 and 5, is going to be at +1. So let's put a midline here at +1. Now let's go ahead and verify that the distance from the midline to the max and the midline to the minimum is the same. So midline to the max, that's going to have a distance of 4. Midline to the minimum, or to a minimum, will also have a distance of 4. So the amplitude is that positive distance. The amplitude is 4. Okay. Looking at number 6 now. Again, we want to find the period of the graph provided. Notice this one is different from number 4 in that number 4 looked like either a sine or a cosine wave. Number 6 looks like a tangent function. So same idea though, the period is still the horizontal length of one complete cycle. And one thing that we can do with tangent functions is we can look for clear, easily identifiable points. So notice that I have a point here at 0, 1, and that point for that part of the cycle is going to correspond to the point at 3 pi, 1. So if we find the horizontal distance between the two, from here to here, 0 to 3 pi would have a period of 3 pi. That would be answer choice D. All right, moving on to number 7 here. These are the kind of questions you can more so expect on the quiz. So which function below best matches the graph provided? One thing we want to look at is, can we identify any changes in the amplitude, the vertical shift, the period, any phase shifts perhaps? So let's take a look first at the amplitude. We're looking here, and let's go and identify the midline. It's looking like the midline will be here at -2. And looking at the midline, from midline to minimum or midline to maximum, either or, we're going to have an amplitude of 1/2. So amplitude equal to 1/2. One thing that I like to do, especially if this is a multiple choice scenario, is I'll go ahead and start eliminating some of the wrong answers based off the amplitude alone. So looks like I can go ahead and eliminate C, and I can eliminate D, because neither one of those has the correct amplitude. Now we can look at the vertical shift. So looking at the vertical shift, typically for sine and cosine, The midline will be at the x-axis, or y equals 0. Notice that the midline has shifted down 2, so we have a vertical shift of down 2. Well, looking at our remaining answer choices, both of them have a vertical shift of down 2, so that doesn't help us too much. However, the period is going to help us. So let's identify the period here. And it looks like one complete cycle will go from 0 to pi over 2. So the period is going to be pi over 2. Now recall that for sine and cosine, the period is equal to 2 pi divided by b. Well, since we know that the period is pi over 2, this means that pi over 2 is equal to 2 pi over b. Through cross multiplication, this is what we would get. We would get b times pi equals 2 times 2 pi, which is 4 pi. And then after dividing pi on both sides, we get that b equals 4 pi over pi, which means that b equals 4. So looking at our answer choices, that would give us answer choice A, because the b term, or the term being multiplied to x on the inside of the parentheses, is a 4. All right, looking at number 8, which function below best matches the graph? Notice this time we have a tangent function. We know that tangent can be a little bit more difficult than sine and cosine at times. So let's see if we can start to identify either some period changes, vertical shifts, phase shifts, A changes. Remember that for a tangent, we don't have an amplitude, so to speak, but we can still vertically stretch or shrink the graph based off the A term. So let's think about the period first. So again, for tangent, we want to look for points that are easily identifiable. I can see a point here at 3 pi over 4, comma 1, and at 7 pi over 4, comma 1. So if I look for the horizontal distance between the two, well, from 3 pi over 4 to 7 pi over 4, that's a distance of 4 pi over 4, which is just pi. So we notice that the period is pi. Now think back to the parent function of tangent. The parent function of tangent already has a period of pi, so the period did not change. Since the period didn't change, that means the b term is still a 1, because the b term for the original, the parent function of tangent, is also a 1. So the period remains unchanged. That means the b term remains a 1. That means that we can go ahead and get rid of answer choice D, because when you look at answer choice D, the period was the b term was a 2. Okay, now let's think of vertical shift. Well, if you think about the original graph of tangent, these points would have rested on the x-axis. So with these points being shifted up 1, we know that we have a vertical shift of up 1. Let's be consistent with our colors here, up 1. However, if you look at your answer choices, they all have vertical shifts of up 1, so that's not going to help us too much. Let's now think about the A term, so to speak, how much we might be stretching or shrinking our graph by. Well, we talked about in one of the lessons about the distance from the asymptote to that point in the middle. So here's our asymptotes. We have an asymptote at pi over 2. We have an asymptote here at, pi over 4. Then we have one here at 5 pi over 4, and so on. And if you look at that point in the middle, so here's the point in the middle of those two asymptotes. If we look at the midway point between the point in the middle and the asymptote, which would be right here, we want to find out what's the vertical distance from that point to the point in the middle. And it looks like that vertical distance is half. So we have an A term of 1/2. So that means we can go ahead and get rid of answer choice A, that has an A term of 1. So now looking at the remaining answer choices, one has a phase shift of left pi over 4, C has a phase shift of right pi over 4. So we need to figure out which is the correct phase shift. Well, when you think about the parent function of tangent, let's go ahead and graph it here just so that we have a good idea of what's going on here. So when we think about the parent function of tangent, y equals tangent of x, let's go ahead and change our steps to be pi over 4, Okay, so here's our parent function. Notice that for the parent function, again, one of those middle points between the asymptotes is at pi. Well, if we look at our new function, our transformed function, the point in the middle between the asymptotes has been shifted left to 3 pi over 4. So that means we've had a phase shift left pi over 4, which would be answer choice B. Remember that for phase shift or horizontal shift, plus means left, minus would mean right. All right, let's look at problem number 9 here. Which graph below best matches the equation y equals 4 sine of x plus pi halves plus 2. This is a sine function, so let's think about the amplitude here first. Based off the equation, the amplitude should be 4. So let's go ahead and eliminate some wrong graphs. It's pretty clear to see here that B is not going to have an amplitude of 4. B has an amplitude of 1, actually. Also, answer choice D is not going to have an amplitude of 4. It instead has an amplitude of 2. So we can see in both A and C, from midline to the top, that's 4. From midline to the bottom, because -2 to -6, that's 4. Same thing for answer choice C. Here's my midline. Midline to the top, that's going to be 4. Or midline to the bottom, that's going to be 4. So A and C both have the correct amplitude. Now let's look at the phase shift and the vertical shift. Well, the phase shift is telling us, let's go to the left pi over 2, because we can see this plus pi over 2 in the parentheses. So phase shift, left by pi over 2. And the vertical shift is going to be up 2. Okay, so looking at the 2 that we have remaining, remember that for the parent function of sine, the midline would be the x-axis. Well, if you look at answer choice A, the midline actually got moved down 2. So this has a vertical shift of down 2. Here, there's our midline for the parent. Here's our shifted midline. This vertical shift went up 2. So C would be the correct answer choice here, because it's the one that has the vertical shift of up 2. So in this particular case, we didn't even need the phase shift left pi over 2, but if we did need it, we could see that in answer choice C as well. All right, and then the last problem for this section of the review, there'll be another Unit 1B quiz review put up tomorrow. So we will find the graph that best matches the equation y equals 2 tangent of x over 2. A couple things, let's look at the A term. So for tangent, again, we don't have an amplitude, but the A term is still significant. It tells us how much we are stretching the tangent function vertically. So we have an A term of 2. And let's also look at the period. So we know that the period for tangent is pi divided by the B term. Well, here we can see that the B term is 1/2. Remember, there's an implied invisible 1, so to speak, here in front of the x. So the coefficient is 1/2. So the period would be pi divided by 1/2. And remember, we're taking pi, dividing it by a fraction, so this would really be pi times 2 over 1, which would be 2 pi. So we want to find the graph that has an amplitude, or not an amplitude, sorry, a period of 2 pi. Well, let's look at these one by one. So answer choice A, 0 to pi over 2, that's a period of pi over 2. So I'm going to go ahead and eliminate that one. If I look at B, we have a period from 0 to 2 pi, so that has the correct period. We'll keep that one in for right now. C, 0 to pi over 2, so that also has a period of pi over 2. We'll go ahead and get rid of that one. And then D, 0 to pi, that has a period of pi. That's incorrect. We'll get rid of D. So it turns out we didn't even need the A term because A, C, and D all had the incorrect period. So B is the correct answer, and we are done.